Okay, we are all set. Over to you, Chetna ma'am. The virtual stage is all yours.
Thank you for introducing me. It's great to see you all, to meet you all, and thank you for joining this webinar. My name is Chetna Bokade. Let me share my screen. Please let me know when my screen is visible.
It's visible now, ma'am.
Thank you. So I think we can start now.
Yes, ma'am.
So today I will be explaining how can we do exploratory data analysis for best bookseller dataset using Python on Jupyter Notebook. Before we start, let me give a brief introduction about myself. So I'm working as a senior software developer at Accenture. Before this, I have also worked at Tata Consultancy Services as a software developer. I have 5+ years of experience in Python programming language, SQL, Automation Anywhere, Linux, and shell scripting. And now I'm also working on data analysis and visualization. And in my free time, I like to sketch and cook. So let me move forward. So now let's see what all topics I will be covering today. First of all, I will be giving introduction of EDA. Then we will see the steps to perform EDA. After that, I will we will also see the types of feature analysis. And after that, I will be explaining how I have performed the EDA on best bookseller dataset on Jupyter Notebook using Python. At the end, we can discuss all your questions that you will be having. Now let's start with the introduction of exploratory data analysis. So it is a process of examining or understanding the data. Using this process, we can extract meaningful insights or main characteristics of the data. Data scientists use EDA to analyze and investigate data set, and they summarize the main characteristics of data set. They use visualization methods like plotting graphs and different charts to uncover and reveal required knowledge from the data. They also find out the trends and patterns hiding behind the data. Okay, now here are the steps to be performed for EDA. First of all, we need to do data sourcing, which is collection of data in a CSV file or Excel file. Then gathering the requirements, which means collecting all the questions to which we will find out answers as the output of this activity. Then examining or understanding the data set. Then we need to handle the missing values or outliers and convert the feature of object data type into string data type. Then if required, we need to categorize the numerical data into categorical data. After all these steps, we can finally start working on finding out the answers for the question we noted in the second step. So, okay. Okay, so here comes the types of feature analysis. First is categorical feature analysis. Second is numerical feature analysis. So first we will talk about categorical feature analysis. It has three types. So categorical means those features which belong to a particular category. Okay, like gender, female and sex. This is the example. So first one is univariate analysis. It is a single feature analysis. The example is feature versus count or frequency. You can also calculate mean, median and mode, which comes under univariate analysis. The charts can be used are line chart, bar plot and histogram. Second one is bivariate analysis. To find relationship or correlationship between two different features, we use bivariate analysis. Examples are temperature and ice cream sales in summer season. The charts can be used as scatter plot, regression plot, stack bar, and bivariate line chart. Third is multivariate analysis. It is used to find the correlation or relationship between two or more features. For example, it can be used to compare the popularity of 4 different advertisements on a website. The charts can be used are scatter plot, regression plot, stack bar, bivariate or multivariate line chart you can use. We can also use heat maps. Okay, then we come to the second one, which is numerical feature analysis. It is done for all the features which are numeric or float in nature. So first one, the first type is correlation. It is used to test a relationship between variables. For example, you can see the correlation between your calorific intake and your weight. Charts can be used as scatter plot and regression plot. Second one is trend. It is used to find trend or patterns of variables over a period of time or year. For example, temperature variation per year. Charts can be used as line chart or bar plot. Third one is distribution plot. It is used to find the pattern of frequency of a variable, number of occurrence of a variable. The examples are frequency of medals won by Team India. Charts can be used are bar plot and pie charts. So now let's move on the hands-on of this where we will see how can we do the exploitative data analysis for best bookseller data set. Okay. Can you see my Jupyter notebook?
Yes, ma'am.
Okay. So before we start the analysis, you can see I have noted down some questions. So at the end of this activity, that is exploitative data analysis, we want the questions of these answers. So these questions belong to the information related to the data set. So we have I have noted down 8 questions. You can add more questions if you want, but for this session, I have noted down 8 questions. So the first question is that we will see is authors with the highest user rating. Then we will see a book name with highest and lowest number of reviews. Third is book name with highest and lowest price. Fourth is year with highest and lowest number of sales. Fifth is count of fiction and non-fiction books. Then we will see how we can categorize the user rating. The user rating is a numerical data type, and we will categorize it into categorical data. Seventh one is price comparison between non-fiction and fiction books. Eighth is book prices with lowest and highest sales. So in this analysis, we will try to find out the answers of all these questions. So now let's start with the first step, with the next step, that is study the data sets. Okay. So to start with exploitative data analysis, we will need, as you know, that we will be doing the EDA with Python. So I am importing some of the Python libraries. First one is pandas as PD, then numpy as npy. Then I will be using matplotlib, pyplot for plotting the graphs. Then I will be using seaborn. Okay. So now here you can see that I'm creating a variable or an object of data frame, and I'm using a pandas. I'm using the read CSV function of pandas, and I'm passing my file name. This is my CSV file. Okay, so this is my CSV file where all the data, it contains my data set. So I'm reading that CSV file, and I'm putting that into a best cell variable, or say object. So best cell object dot head. So we are using head function to see the top 5 entries of the data set. Here we can also see the index. The index is starting from 0. And we can also see the column names, which are name, author, user rating, review, price, year, and genre. Then I'm using a second function called shape. So shape is returning me the number of rows and number of columns the data set is having. That is 550 and 7. Then I'm using a describe function. So this describe function is returning me some statistical data of my data set. But here you can see the numerical column only I'm getting. So it is returning me the count, mean, standard deviation, minimum value, maximum value, and also the 25th, 50th, and 75th percentile of the data, only for the numerical data. Then I can also use the columns function to find out what all columns I'm having in the data set. These columns we have already seen. Then one more function I'm having, which is a value count. So this is giving me again the same data set it is giving me, but here you can see I'm getting the index. So I'm getting the index from 0 to 549. Then I'm using a function called info. So this is giving me the information about the data set. So here you can see the best cell is a data frame. It is a type of data frame. The range index is from 0 to 549, and we are having 550 entries. We are having total 7 columns. Then the name of each column is given and the particular index is given. These are not null, and the count of each column is 550. The data type of name, author, and genre are object. The data type of user rating is float. The data type of review, price, and year are int. Sorry. So we have now got the information of data set. Now we will check if the data set is having any missing values or not. So for that, I'm using the data frame object. IsNull is a function which will return me uh, if the data set is having any null value. Sum will return me the sum of the null values of the data set, and sort values will sort the output in ascending order. So here we can see I am getting the name of column and 0. So it means that the data set is not having any null or missing values. So here we are getting the count of missing values. But if you want to get the percentage of missing values, then how you can do it? We can see that. So here you can see I am using again the same data frame object is null to return the null values, and sum that I am dividing by the shape 0. So shape 0 will return me the number of total rows. That is 550 multiplied by 100. And I'm using a round function and comma 2, so it will return me the values after decimal. 2 values it will return me. So here you can see in the percentage also I'm getting 0, so it means the data set is not having any missing values. So if your data set contains any missing value, so how can you handle them? There are different methods to handle the missing data. So method 1 is replace with fixed value. So how you can do that? Suppose you have some null value in the price column. So you have to write the data frame in the square bracket. You have to write the name of column. Then you have to use the replace function. np.nan represents a null value that you want to replace with 0 or any value that you want to give, and then you have to pass in place equal to true. So if you pass in place equal to true, it will do the changes in the original data set, that is the best cell. So this is the first method. Then second method is replace with mode or median. So here we can see if you don't want to replace with a fixed value, if you want to replace with a mode value or median value, then how you can do it? So same thing, the data frame object and the column name. Then you can use fill NA. This function will fill the null values of the data set with the value best cell price dot mode and 0, and in place equal to true. We will see why I'm passing 0 here. Similarly, if you want to replace with median, so the same command you can use. Just here you can use the median function. So in this way you can replace with mode or median. So why I'm using 0 in the mode, that we can see here. So if I print the mode of price, then it is giving me 8, okay, and it is the index. So I want the value at 0th index. That's why I'm passing 0 here. So it is returning me 8. That is the mode of the price. And median is simply giving me the median. So here I don't need to pass any index. Okay. So after this, we can see that to replace more than one column, if we have more than one column where we want to replace, so then we can definitely use a for loop of Python. So for column in a list of columns, you can pass here. So best cell column that we are using here, column, then we can fill it with the median or mode, whatever you want to replace it with. So this was the second method. Third method is you can drop the columns which are not required for the analysis. So sometimes some columns are not required for the analysis. The question that we have written above, maybe some columns are not required for those analysis. So what you can do, you can make a list of those columns which are not required, and then you for the data frame you can use a drop function. You can pass the list as a labels, then axis 1 represents the column and in place equal to true. So this will drop the columns which are not required for the analysis. So these are some methods to handle the missing data. As of now, I'm not having any missing data, so I'm not performing any such replace, fill any, or drop action. We will move to the next step, which is checking the outliers or handling them. We will see how we can handle them. So to check the outliers, this is the best way. You can use a box plot. So you can use a Seaborn. You can use a Seaborn library to do that. So sns.boxplot you can use. Then you need to provide some parameters. First one is the x-axis, that is genre I'm providing. Then you can provide the y-axis, which is a price, and data equal to best cell. So here you have to provide the data set. So here you can see we got a plot, genre versus price. So we have two genre. First one is non-fiction and fiction. So here we can see most of the data is lying between 0 to 20, and after 40, after 30, I think, yeah. So after 30 there are some outliers. These dots represent these are the outliers, but maximum of the data lies here between 0 to 20. So this is how you can check. So here we can see that yes, some outliers are there. Okay, then this is another plot, box plot. This is the same box plot I have shown here, but here I have also shown the distribution plot. So here also the same thing I'm representing, that between 0 to 20 the maximum data is lying here, and after 40 there are some outliers. So how I have plotted this? So first of all, I have given some figure size. Sorry. So to plot these two graphs in the same page or in the same line, I'm giving some figure size 20 by 20 comma 5. So you can modify that as per your requirement. Then since in the same line I'm plotting two different plots, so for that I can use a subplot. So what subplot will do, this function can will allow me to plot two different graphs in the same line. So as you can see, I'm giving the positions here, what position I would like to have here. Okay, then I'm using the same box plot. So this is the same code here. One thing I'm doing here, you can see I'm printing the title. So here I have used price box plot as a title, then font size, color indigo, and padding I'm giving here. Then I'm plotting a second plot, which is a distribution plot. So for distribution plot, I'm passing some parameters like price. Okay, on the x-axis I'm passing the price, and I'm passing the color green as I wanted. Then I'm setting some title, font size, color, and padding. So this is how I have plotted these two plot. But here the same information is there, that it can be inferred that most of the books cost between 0 to 25, and there are the books which cost a lot more, but they are less or they are rare or less in number, which are the outliers. Now, here is the box plot of genre versus reviews. So I can see for non-fiction and fiction, the number of reviews are mostly between 0 to 20,000, but there are some outliers also, as you can see the dots. So again, I have plotted the same, this is the same code. The difference is just the review column. So again, I'm using the same box plot. So here you can see the So first method is we can replace the outliers with the fixed value. So the outliers will lie here or they will lie here. So hello, am I audible?
Yes, ma'am, you're audible now.
Okay. Shall I again share my screen?
Yes, ma'am.
Okay. Sorry, I got disconnected. Don't know how.
No issues, ma'am.
Okay. Is my screen visible again?
It is loading. Yes, it's visible, ma'am.
Okay. So have you heard till here? Wait. Till here?
You can continue, ma'am.
Okay. So I will continue from here. How can we handle the outliers? So the first method is we can replace the outliers with a fixed value. That is, here I'm giving an example where I'm replacing all the books with price above 20,000 with 25,000. So how can I do that? So I'm using the data frame object, the column name, and I'm using a numpy function dot where. So it is like running a SQL query. So wherever we see where the best sell price is greater than 20,000, I'm replacing it with a 20,000 value, and the column that will be updated, it is the price column. So this is how I'm replacing with a fixed value, that is 25,000. Then you can replace the outliers with the median. So here or with mode also you can replace. So again I'm using the same function, where function of numpy. It is again similar to the SQL query. So I'm replacing all the prices which are greater than 20,000 with the median of all the prices. Okay, and I will be updating the price column. So this was the second method. Now third method is a bit tricky. So here we will be removing the outliers. So to remove the outliers, we can use this Python function. So this Python function are taking two parameters. First one is the data set, then second one is the column name. Then I'm just initializing some lower range and upper range variable. Then I am finding out the quartile ranges. So for this, we can just understand the box plot only. Let me explain you that. How can I remove this? Okay. So here you can see this is again a box plot. So we are getting a box here. So first thing is the lower quartile, and second thing is the upper quartile, and this is the median. So most of the data lies between under the box only. Okay. So how we will treat the outliers? The outliers will lie here or they will lie here. So we will keep all those rows which are lying between lower quartile and upper quartile. Anything lying above upper quartile or below lower quartile, um, those columns, sorry, those rows we will not include. So how can we do that? Okay. So for that only I have written a function. So this will return me the third quartile, that is the 75 percentile. And this will return me the first quantile, that is the 25 percentile. So I will get Q1 and Q3. Now the range in the box, it is known as the interquartile range. So that is calculated as Q3 minus Q1, that is third quartile minus first quartile. Now to find out the lower range and upper range, that is the range of the box only. For that we have this mathematical formula where okay, sorry. Okay. So how you calculate the lower and upper range? Here is the formula. So we multiply 3 by 5, that is 1.5, with the interquartile range, and that is subtracted by Q1. So this is how we will get our lower range. And to find out the upper range, again we multiply interquartile range with 1.5 and add it to the Q3, that is third quartile. So now any data which is lying between lower range and upper range, those data we will keep, and those are not lying between this range, that we will not keep. So in this way, we will remove the outliers. And we are returning the range only here. So now here you can see I'm calling this remove outlier function. I'm passing the data set, okay, and I'm passing the price as the column. So when I call this function, it will return me the upper range and lower range. So now I will be updating my data frame or my data set as I will be using data frame and dot log function. Log is used to access a particular location of the data set. So here you can see the price which is lower or equal to upper range, and the price which is greater or equal to lower range, that one only I'm keeping and putting into my data frame. Anything which is not coming under this range, that is lower between the lower and upper range, that I'm not keeping. So in this way I'm removing the outlier. So as of now, I have not handled the outliers because it was okay for me for this analysis. But you can use this method if you want to handle the outliers. It totally depends on the requirements. Okay, so I will move to the next step. So here I'm checking the unique values of each column. This is again to understand the data set. Like the first thing, I'm printing the columns of the data set. This we have seen already. Now, for this column, for the genre columns, I want to see what are the unique values of this column, just to understand the data set only. So here, when I use a dot unique function for this column genre, so it is giving me the two unique values, which is non-fiction and fiction. Okay, so genre will be either fiction or non-fiction. Only these two value exist for genre in this data set. Then you can see I'm using a value count function. So again, it is giving me non-fictions are 310 and fictions are 240. Then you can see I am using one index and values. So these are very important to plot the graphs. So here you can see I'm using the value count function only and dot index. So it gives me the objects or the main data. So here you can see if I'm using index, it is giving me non-fiction and fiction in the output. The unique values it is giving me. When I'm using values in the place of index, when I'm using values, so it is giving me the count of object, that is 310 and 240. So for non-fiction we have count 310, that it is returning me, and for fiction we have 240, which is it is returning me. Okay, so these two things we will use a lot of times. Then best price dot unique. So best sell price dot unique. So here I'm getting the unique values of the price. Okay. Then value count and sort values. For sorting the values, I'm using a sort value function in ascending order. So sorry, in descending orders. So for that I'm passing ascending equal to false. So these are the values of the price 8, 16, 9, and 5, and these are their counts 52, 38, and all. Again, you can see if I'm passing index for the price count, value count, then I'm getting the objects or the values of the data set. But when I'm passing the values, I'm getting the value count. That for 8 we have 52, like we have 52 books which have price equal to 8. Then I'm seeing what are the unique years I'm having. So I'm having between 2009 to 2019, and for each value, for each year we have a value count of 50. So I think for each year the 50 number of books have been sold. Now I move to the next step, where I'm changing all the values of column with data type object into string. This is an important step. So we should always have the data type into string or integer. String because that can be treated as a categorical data. So here you can see in the info, we can see that name, author, and genre, they are in object. Those we want to convert into string. So how we can do that? First, I am extracting all the columns name which are having the data type equal to object. So you can see I'm using the data frame object dot select data type, which includes a data type that is object. So that is returning me a list which is name, author, and genre. All these three columns are having data type equal to object. So that I will be converting it into string. So what I'm doing, the data frame dot log to access the location of the object, then data frame dot log, and I'm using a apply function. I'm using a lambda function to change into string type. So it will return x, which is x dot as type as string. So this will convert all the data type which are having the data type object. So that will be converted into string. Okay, so now we will work on all the questions that I had written, 8 questions. So first thing is we need to find out the authors with highest user rating. So how can we do that? So first of all, I'm printing the user rating of the particular uh, data frame. So we can see we have different rating, and the index are between 0 to 549. So I will be accessing the user rating column. Now here you can see I have a space in between. So that was giving me a problem. So what I have done, I have renamed the column with the name user rating, and I have removed the space because it is giving me some error. So I have removed. This is how we can rename a particular column name in the data set, and I'm using in place equal to true to update the actual the original data set. Then you can see this is my data frame. I'm using a query function. So, and I'm passing the parameter user rating equal to 4.9. Okay, because we need to find the highest user rating. With the highest rating is 4.9. So I'm running it as a SQL query. So it will return me all the best authors. So in the best author, I will see the name of all the authors which are which have got the user rating equal to 4.9. So you can see all these authors have got the user rating 4.9, that is the highest rating. Okay, now using the index one, we have already seen that we get the objects, the real objects from the data set, and values gives us the count. Okay, so now I will be plotting the name of author versus their count. Okay, so again I have given the figure size 20,5. Then I'm using a bar plot. Okay, the x-axis I'm providing is the best author column and value count index. So in the x-axis I am passing the name of all the authors, and in the y-axis I am passing the values, that is the count of those authors, and I'm setting some title. Okay, font size, then color and padding. So here you can see we have got the plot. So here on the x-axis we can see the name of authors and their particular number of ratings. So here we can see that all the above authors got 4.5 4.9 user rating, and Dr. Seuss got 4.9 user rating 8 times. So he has got the maximum number of times he has got the 4.9 rating. So we can see he is the best author. So here is the answer of our first question. Moving to the next one. So next question was to find out the book name with highest and lowest number of reviews. So to get a maximum number of reviews, I'm using a max function. So I'm using the data frame column name dot max function. So it will return me the maximum value of this column, that is reviews. So it is giving me the max review, which is 87841. So these are the maximum number of reviews. So now what we want the book name. Okay, so I can print the entire row of this particular number of reviews. So how I'm doing that? I'm using the data frame. In the bracket I'm passing. It is again similar to running the SQL query. So you can see I'm using the data frame and the column, that is reviews, where it is equal to the reviews dot max value. So wherever I am getting the maximum number of reviews, that particular row I want to print. So in the output you can see that we have got the same reviews as printed here, and the name is where the crawded sing. So this is the name, this is the author name, and the user rating, everything you can see here. Okay, so the book with name where the crawded sing has got the highest number of reviews, that is 87841. Similarly, we can use the min function. So using the min function, I am checking which book has got the minimum number of reviews. So here I got the reviews, that is 37. This is for this book and this author. So this one has got the lowest number of reviews. Okay, so here I didn't use any graph or chart, just simply using this function, we can find that minimum and maximum function. Third question is find out the book name with highest and lowest price. So again, the same thing I have done. In place of review, I have used price. Okay, so I'm returning the rows which are having the price equal to the maximum price of the particular data set. So here you can see we have got it. So two books, I think the name is same and author name is also same user rating. The price is also same. Okay. Then okay, so here I'm printing. Okay, so here you are getting in the in a table format, but if you just want the names only, so how you can do the same query, the same code I have written here till here. Okay, then after that, from this data set, now I want the name and their value count and index. So this is returning me only the names. This names only it is returning me. Okay. Then here I'm finding the book with the minimum price, again the same code, only have used the minimum function. So these many books are there which are having the minimum price, that is 0. Okay. And this is again the same code where I'm printing only the names of the books which are having the 0 price. So here is the list of those books. Okay. Now the fourth question is related to finding out the year with highest and lowest number of sales. So that one I have done using a bar plot. Okay. So what I have done is, okay, I'm using a Seaborn library and its count plot function. So count plot gives me as I'm passing year, so year versus count, it will give me a count plot will give me. So in the x-axis, I'm passing year and I'm passing the data set. Okay. Then I'm storing the output into a variable called C. So why I'm doing this? So if so here you can see above each bar I am printing the value also, like the value of this bar is 50. For each bar the value is 50. So how I'm printing this 50 above the bar? So that I'm doing using this for loop. So this C will contain some containers. So for each container, using this object, we are labeling the bar using the bar label function, and we are passing the value of container. So in this, so this container will contain the value of each count, and it will print just above the bar. Okay. So here we can see that in all the years, equal number of sales happened for all the books. Okay. Then we come to the fifth question where we are counting the fiction and non-fiction books. So again, the same code I'm using. I'm just printing the genre versus count. Okay. So here again, I'm using the count plot function. I'm passing a genre in the x-axis, and in the data, I'm passing the data cell, sorry, the data frame. So here I'm again using the for loop to label my bar. So here you can see I'm getting the count above each bar. I'm getting the value, that is for non-fiction they are 310, for fiction one they are 240. So count of non-fiction are 310 and count for fiction are 240. Okay. Next question is, so here we will be categorizing the user rating. So user rating we are having in the form of like from since this is the best bookseller data set, so we are having the best data set, the best user ratings only. So it is between 4 to 5, the ratings we are having in our data set. So now what I want to categorize those. Like suppose so I'm using a I'm defining one function which is bin rating, and I'm passing the value of user rating into that. Okay, so what I am doing is if the rating is between 4.0 to 4.2, then I'm returning one time watch. So those reviews which are user ratings which are between 4.0 and 4.2, those I'm categorizing as one time watch. Okay, then the if the user rating is between 4.2 and 4.4, so those I'm categorizing as average, so I'm returning average. Similarly, when it is between 4.4 and 4.6, I'm returning hit. If it is between 4.6 and 4.8, I'm returning super hit. If it is between 4.8 to 5.0, I'm returning a blockbuster. So here you can see I'm categorizing the numerical data into the categorical data. So after this, what I am doing, I'm using the data frame object best cell. I'm creating one new column, which is my categorical column. Then what I'm doing, I'm calling this bin rating function. I'm passing the I. I is I is the value of user rating. Okay, so I'm passing each user rating to this bin rating function, and it is returning me the category, which category it belongs to. Then I'm after updating my data set, I'm printing the head of 10. Head of 10 will print the 10 top rows of the data set. So here we can see we have added one more column which is bin rating. So we have categorized the user rating into bin rating. So here you can see if it is between if it is 4.7, which is between this 4.6 to 4.8, so that one I am categorizing as super hit. And you can similarly you can see for for each row, for each user rating, we have got a particular category. So this is how you can categorize the numerical data into a categorical data. Now using this, we will do some analysis. So okay, the bin rating value count index, so it will return me the unique values of this bin rating column, so which is super hit, blockbuster hit, average, and one time watch. Then I'm printing the unique values of the year. Okay, so I have got the years between 2009 to 2019. Then I'm creating a new data set using my old data set. So in the new data set, I'm putting all the so wherever the bin rating is equal to blockbuster, so that I am putting into the BB data, that is blockbuster data. So here, and I'm printing that blockbuster data. So you can see I have got all the data which are having the bin rating equal to blockbuster. Okay, so now I'm plotting on the x-axis, I'm plotting year, and I'm passing the data set which I have created here. So this BB data I am passing here. So it is giving me year versus count. So so in year 2019, here we can see in the year 2019, we can see we got the maximum number of blockbusters, which is 32. And in the year 2010, we got the minimum number of blockbuster, which is 7. So this is how you can do the analysis year wise. Okay. Now similarly, Similarly, I have created a new data set, which is a flop data. So in this flop data data set, I'm putting all the rows which are having bin rating equal to one time watch. So okay, so again the same code in the x-axis I have passed the year and the data is flop data. Okay, so here we can see we have plot the year versus count. So in the year 2013 we have got the maximum number of flop, which is 4, and in the year 2017 we have got minimum number of flop, that is 1. Okay, so this is how you can categorize the data and plot and create these plots according to your requirement. Okay, this is our seventh question where we are finding the where we are checking the price comparison between non-fiction and fiction. So to do that, I have just given a plot figure size I have given. Then I'm again using a bar plot. In the x-axis I have passed the genre, and in the y-axis I have passed the price, and I have passed the data set to the bar plot function. So here we can see genre versus price. So for non-fiction, we can see the price is between 14 to 16, and for the fiction, the price is between 10 to 12. So non-fiction books have higher price than the fiction books. So this is how we have done the price comparison between fiction and non-fiction. Here is our last question, question number 8. So here we are seeing the book prices with lowest and highest sales. Okay. So firstly, I have printed the price value count index. So these are the prices, okay, the value of prices. And here I'm printing the values. So this is the count of these price. Like for 8, we have 52 sales or values. Okay. Now here I'm plotting. So I will be plotting on the x-axis. I will be plotting the index. Okay, that is the value of these objects, and here is the count of those objects that I will passing in the x-axis. So you can see in the x-axis in the y-axis. Sorry. So in the x-axis I have passed the index, which is these values, and in the y-axis I have passed these values, the count of the objects. Then I have set some title, font size, color, and padding. Okay, and I'm again using the bar plot only. So here you can see in the x-axis we have got 0, 1, 2, 3, and these are the price values. This one. Okay, and in the x-axis we have got their count, their values. Okay. So from this plot, we can see that the book with price 8 have the highest sales, that is 52. Yeah, 52. And books with price 54, 3, 9, 53, 1, 36, 82, and 42. You can see here the minimum size of the bars. So they have got the lowest sales, and I think that is 1 only. Okay. So these were the question, and this is the way we can find out their answers. And here you can see again I have noted down, this is a conclusion of this notebook. So here are all, again I have written all the questions here and their particular results here in the conclusion. So that is it from my side today. Please let me know if you have any questions. We still have 7 minutes. Okay, so I think Analytics Vidya will be sharing you my LinkedIn profile. I have shared with them. Thank you so much. Anything else, any questions you are having, please let me know. Or you can also ping me in the LinkedIn if you have any questions.
Yeah, so thank you, ma'am. On behalf of Analytics Vidya, I would like to thank you for your time and delivering such a wonderful session. I'm sure our audience found it insightful, and hopefully we can conduct more such sessions with you in the future. So guys, we have put up a feedback poll. Please let us know how was the session. And ma'am, we have some questions in the Q&A section. Please, if possible, take them.
Okay. Okay, so we have used Seaborn. You can see I have used a bar plot function. So for plotting bar plot, or you can the Seaborn library also have some other plots that you can use to plot it. So that's why I have used Seaborn. Okay, what happens for the categorical data if we give describe function? Okay, so when we use describe function, we only get the statistical data for the numerical value. We will not get it for the categorical data, because the categorical data don't have mean, median, and mode, standard deviation. All those data are only applicable for the numerical data set. For categorical data, we don't have such percentiles or means. That is only for numerical only. Okay, so that depends. For example, if you are working in a project, you can discuss with your managers, team leads, and it also depends on the requirement. For example, if you have suppose if you have some column which will be not used in your data set, then you will not include that, so that you can discuss with your managers or your lead to understand that thing. Okay, so if you study the box plot in detail, the quartile topic in detail, so there you will see we only have three quartiles, like first, second, and third. So for second one is the median, and first and third are the range. So where the maximum data lies between. So that's why we do Q3 minus Q1, third quartile minus this first quartile. Yeah, I will be definitely sharing the notebook. I have already shared with the analytics Vidya. So if I think they will be sharing. If not, then I can share it with you definitely. Okay, so padding is to you can see between the bar. I think between the bars you can see some gap. So that is the padding, or also the width of the bar. That is also the padding. How to install Jupyter Notebook? Okay, so Jupyter Notebook you can use from the Google Colab directly if you don't want to install. But I have first installed the Anaconda, and so first you can install the Anaconda, and from there you can easily launch the Jupyter Notebook. So let me try. I don't know why this is not opening. So this is the Anaconda which I have installed, that you can directly install from the so you can in the Google you can search how can I install Anaconda, and once that is installed, there are many editors like Jupyter, Spider, so many things are there. So from there you can get the Jupyter Notebook.
So I think that is all. Thanks a lot, ma'am, again. And I hope you guys have filled in the feedback poll. If not, I request you to please fill in the form. It helps us to conduct more such sessions. And we will be back with another session of the Data Hour on 22nd Feb. The link is in the chat section. Till then, bye-bye and keep learning.
Thank you everyone. Thank you so much for joining.